we are looking at percentages. So we'll first focus on what are they and what's the point of them. We'll do some subtopics, and then we'll finish off with some exam style questions at the end. So percentage, well, percent just means per 100. And, if we're talking about maybe, 42% of the population has blonde hair, well, this is saying 42 out of every 100 people has blonde hair. Out of 100. And, as a fraction, 42 out of 100 is just 42 over 100, right? So this is how we can convert from percentage to fractions. Also, 42 over 100, or 42 divided by 100, this just gives us 0.42. And so we can actually also convert from percentages to decimals. We can see we just divide by 100 to convert from percentages to decimals. Percentages, in taking a step back, they're very useful for talking about, percentage change in things. At the moment, you may have seen news articles about the inflation rate, it's, 10.2% or something. Well, it's very useful to be able to talk about how things are costing more relative to what they cost last year, right? It's the easiest way to do that is with percentages. Or, if you ever go shopping for, clothes or whatever, you might see it's a 15% discount. Well, it's very useful to be able to appreciate what that actually means. If you see the discounted price is £25, we could always work out what the original price was. Or if you own a shop, you need to know what the new price is going to be if you take off 15%. So, unfortunately, they're kind of pervasive everywhere. We kind of can't get away from percentages. So, finding the percentage of something. So, let's say we want to discount, we own a shop and want to discount a jumper by, 45% or something. Let's do something slightly nicer. Let's say we want to work out, 30%. We want to do a 30% discount. We want to work out 30% of the original price, which was, £48. Well, in this case, there are two ways to do this, right? We can either work out 10% is going to be, a tenth of this, £4.80. £4.8. And then we could times it by 3 to get up to 30%. So 30% is going to be 4.8 times 3. Or what we could do is we could just dive straight in, right? We could convert this percentage into a decimal. We know we just divide it by 100. And 30% as a decimal is going to be 0.3. And again, we just take our original amount and we multiply it by 0.3. So we're doing 48 times, I should lay that out slightly better, times 0.3. Well, you can see in both cases, in both ways of thinking, we're doing the same thing, right? We can either do 4.8 times 3 or 48 times 0.3. Both of these would actually give us the exact same answer, right? We've made the top number 10 times bigger and the bottom number 10 times smaller. So the answer will be the same, just two different ways of thinking about it. Finding something as a percentage. So let's say, let's say we decide that we want a dress in our shop to go from costing £64 down to costing just £24. We want to put a price tag on it and say what the percentage drop in price actually is, so customers can see this. Well, in this case, we want to work out what is 24 as a percentage of 64, or what is the difference between these two as a percentage if we're looking at the percentage drop. So, ideally, we could look at what the discount price actually, what it's gone down by. We've gone from 64 down to 24. Well, we've gone down by £40, right? So we've gone from 64 to 24. So we're actually looking at the discounted amount, how much we've discounted by, as a percentage of the original amount of 64. And this is going to tell customers how much we've lopped off the price. So what is 40 as a percentage of 64? Well, in this case, we're just doing 40 relative to 64, right? It's 40 out of a total of 64. We know in this case, we're literally just doing 40 over 64. Well, this is just a fraction. We know how to deal with fractions. We can simplify them down. if you know times tables, we've got a common factor of 8 in the top and the bottom. We can divide them both by 8, and we get 5 over 8. That's not our final answer, right? We want it as a percentage. This is our aim, to get a percentage. Well, we know 1/8 is just, if you don't know 1/8 as a percentage, a quarter is 25%, an eighth is just half a quarter. So it's half of 25%, which is going to be 12.5%. So 5/8 is going to be 5 times 12.5. That's going to give us 5 times 2.5. That's going to give us 12.5. Add on 5 times 10, which is 50. That's going to give us 62.5%. And that is our final answer. So we've taken off 62.5% of our original price. Percentage change. So again, this is fairly similar to what we just did, right? It's kind of we could be given a percentage, or we can be asked to work out a percentage and apply that to get the change of something. It's really what we just did in the last two topics. I'll do a very quick example. Let's say we want to work out the percentage change. Let's say we've gone from charging, £540 for a TV, and now we only charge £480 for a TV. Well, what's the percentage change? How much have we taken off to go from 540 to 480? Well, it's very similar to this one, right? We've taken off £60. So we want to work out 60 out of 540, and we can just go through the same stages that we did to get down to that result. Let's go on to something more interesting, percentage interest. So this is broken down into two kind of subtopics. We've got simple interest and we've got compound interest. Simple interest is, well, it's simple. It's very easy to calculate. Let's say we put £500 into the bank, and the bank gives us 4% simple interest per year. This is a very, very nice bank. And well, 4% of 500, well, 1% is £5, 4% will be £20. And so every year, the bank is going to put £20 into our bank. So after the first year, after year 1, we'll have £520. After year 2, we'll have £540. And after year 3, we'll have £560. Because every year we just add on the same amount. It's 4% of the original amount that we add on. Compound is slightly different. Compound looks at just the previous year. It doesn't care about what we started with. So again, let's stick with the same example, but in this case, we'll be adding on compound interest. So the first year is the exact same as the above case. After 1 year, we just add on 4% of the previous year. So in this case, it's 4% of 500. So we add on £20. We get 520. After year 2, we actually no longer look at what we had at the start. We only care about the previous year. And so we look at the previous year, 520, and we calculate 4% of 520, and then we add that on to 520. So in this case, 4% of 520 will be £5, 20 times 4 will be £20.80. And so we end up with £540.80. And you can see these two versions are already divergent. Right? We're already 80p richer with the compound interest than we are with the simple interest. And we could keep doing this. What we end up actually seeing is our bank account will actually do something like that. It will kind of exponentially increase in value, right? The more we have in our account, the more we then put into our account next year, and so on. That's why it's always good to be rich, right? This is why people say, money, people with money, get more money, right? It's a simple factor of compound interest. The more you have, the more you get when we're talking about interest. Whereas simple interest, we just add on the same amount each year. It's every single year we just add on a bit extra, right? And we add on a bit extra, and so on. We don't care about how much we've got. We just care about the initial amount that we had in our bank. So compound interest is generally good if you're putting money to account. It's bad if you're borrowing money, right? Because then the lender is making all this lovely money and you are having to pay them that money. Right, let's now look at a couple of example questions. So and buys a dress in a sale. The normal price is reduced by 20%. The normal price is £36.80. What is the sale price? And so if we take off 20%, we're left with 80%. And so really we're calculating 80% of £36.80. Well, again, we could do this one of two ways. We could say, well, 10% is going to give us £3.68. And so 80% is just going to be equal to 8 times this 10%, right? 8 times £3.68. Alternatively, we could just dive straight in and we could convert this into a decimal. We could say this is, as a decimal, it's 0.8, and we can do 0.8 times 36.80. Both methods, and I'm not going to do the calculation, but both methods are the exact same again, right? 0.8 is 10 times smaller than 8. 36.80 is 10 times bigger than 368. And so both of these will give us the exact same answer. Again, it's just two different ways of thinking about this problem. Question 3, Mario invests £2,000 for 3 years at 5% per annum compound interest. Calculate the value of interest of the investment, at the end of the 3 years. And so we're going to take £2,000. If we're adding on an extra 5%, well, we've already got, we're taking 100% of our initial investment, adding on another 5%, we end up with a total of 105% after the first year. And so we just take this, times it by 1.05, right? That's 105% as a decimal. And that's the end of our first year. We then take this end of year amount and we times it again by 105% to get the end of year 2 amount. And then that whole thing will give us year 2. We take this whole thing and we times it again by 1.05 to calculate year 3. And what we're seeing here, right, is we're taking our initial amount, £2,000, and we're timesing it by 1.05 times 1.05 times 1.05. Well, this thing, 1.05 times itself 3 times, is just 1.05 to the power of 3. And so we can put that into our calculator, and that'll be our answer. Right, in general, we take our initial starting amount, we could call it n, and we times it by the percentage change as a decimal. We call this c, and we do it to the power of how many years or how many periods that we're looking at here. We could call this y in this case, and that would be our kind of general formula that we can apply to these kind of questions. And that is the end of percentages.